We will use a ratio test to test the radius of convergence, and we're going to use another test for the endpoints for the interval of convergence for each of these power series. So question A, we have 2x plus 3 to the power n over 4 to the power n, and we're going to use a ratio test. So putting an plus 1 in the numerator, we're going to have 2x plus 3 to the power n plus 1 over 4 to the n plus 1. And in the denominator, we're going to have 2x plus 3 to the n over 4 to the n. Once we set this up, we're going to separate these parts. We're going to group some of these parts. So limit as n approaches infinity. And we're going to group the 2x parts and the 4n parts. I'm going to end up with 4, do the 4n parts first. So the 4 to the power n ends up in the numerator. We have 4 to the power n plus 1, so I'm going to write that as times 4. That's going to be grouped together. And for the 2x plus 3 parts, we're going to end up with 2x plus 3 to the power n, and then the plus 1 I'm going to write as 2x plus 3. And then for the denominator, we're going to end up with 2x plus 3 to the power n. Okay, so we can group that part as well. We can see that there's some parts that will cancel. 4 to the power n, 4 to the power n, 2x plus 3 to the power n, and 2x plus 3 to the power n. The limit now looks like this. The limit as n approaches infinity, we have our 2x plus 3 over 4, and that has to be less than 1. Okay, so once we have this, we can establish our radius and interval. So for the right, I'm just going to multiply this through by 4. So we're going to end up with 2x plus 3. And then that's going to be less than 4. And then we're going to have on the other side of that, 2x plus 3 is going to be greater than negative 4. So I've multiplied the inequality by 4. And so we can then solve for x. We're going to end up with, before I solve for x, I'm just going to use this to establish my center, my C. The C is equal to negative 3 over 2. Okay, so when that is equal to 0, that's going to be our C value, or our center. So then solving, I'm going to solve my right edge. So solving that, I end up with 2x plus 3. Well, I'm going to subtract 3 from both sides. So I'm going to end up with 2x is less than 1. So x is less than 1/2. So that represents my right edge. So at this point, my interval is starting to look like this. X and is less than 1/2, establishing my left endpoint. I'm going to solve that inequality. So I have 2x plus 3, so I'm going to subtract 3 from both sides. 2x is going to be greater than negative 7, so negative 7 over 2 then represents my left edge endpoint. So my inequality looks like this so far. Now, we have our center. Our radius is going to be, in this case here, or the radius is going to be the distance from the center to one of those points. So our radius is equal to 2. Now, is it equal to 2? Yeah, the radius is equal to 2. And we typically can see the radius in our expression because it's going to be the inverse of that, or sorry, the reciprocal of that. Okay, so we have our endpoints. We still need to test our endpoints to see if the endpoints are open or closed. So I'm going to test my left edge. So I'm going to test. I'm going to test the convergence at x equals -7/2. For that, I'm going to substitute in -7/2 into x into my original sum, or my original series. So it's 2 times -7/2. That's going to be -7, plus 3 is going to be -4. So my integral, or sorry, my series now looks like this. So n equals, we're starting at 0 this time. And I'm going to have -4 to the power n over 4 to the power n. So I've substituted my x, and I've worked that out. My numerator is -4 to the power n. So simplifying this, this becomes -1 to the power n. Okay, this is divergent. Therefore, this is an open endpoint. Send this over. Okay, so that represents an open endpoint. So I'm not going to put the equal to on this part here. Okay, so there's no equal to there. So just going to leave it open. I need to then test my right endpoint. So I'm going to test x equals 1/2. My series now looks like this, n equals 0 to infinity. When I plug 1/2 into there, I get 2 times 1/2 plus 3 is 4. So we get 4 to the n over 4 to the n. This simplifies to just 1 to the n, which is really just 1. This again is divergent. Okay, so this is another open endpoint. So that means that it's not equal to that endpoint of 1/2. So we're going to make sure we keep that out of there. So my interval is going to be from -7/2 to +7/2. It's their open endpoints. So we can write it like this: -7/2 to +1/2, and those are both open endpoints.